Assalamu alaikum. I have chosen experiment number 1. So today I will make a presentation on experiment number 1, whose name is measurement of inductance and verification of the rules of combination of inductance, measurement of capacitance and verification of the rules of combination of the capacitance. Moving to the next slide. Whatever will be needed for the experiment: 10 of resistor, 3 ms, 4 ms and 5 ms inductor, and 1, 3 and 5 microfarad capacitor, 2 multimeters, breadboard, signal generator, connecting cords, connecting wires. Moving to the next slide. Everything that should be known. What is capacitance? What is inductance? How to connect capacitor in series and parallel? How to connect inductor in series and parallel? Moving to the next slide. Inductance is the ability of an inductor to store energy, and it does this in the magnetic field that is created by the flow of electrical current. Capacitance is the ability of a component or circuit to collect and store energy in the form of an electrical charge. Next slide. In the next slide, the inductor in the figure on the left is fitted in series for which the formula is LT equal L1 plus L2 plus LT plus dot Ln. On the other hand, the inductor figure on the right is fitted in parallel, for which the formula is 1 by LTL 1 by L1 plus 1 by L2 plus dot 1 by Ln. Moving to the next slide. In this left side figure, I have connected capacitor in series for which the formula is C 1 by C equal 1 by C1 plus 1 by C2 plus 1 by C3. And right side figure I have connected capacitor in parallel, for which the formula is C equals C1 plus C2 plus C3. Move to the next slide. This is experimental circuit diagram. In the experiment, we will connect the inductor and capacitor as load. Procedure: we have to connect the 10 ohm resistor, emitter, voltmeter, 7 volt, 1 kilohertz supply the following loads. Step 1: we have to connect L1 as load, then L2 as load, then L3 as load. Step 4: L1, L2, L3 series combination as load, like this. Series combination like this. Then L1, L2, L3 parallel combination as load, like this. Then like in the inductor, we have to connect C1 C2 separately connection, and then we have to connect C1 C2 C3 in series combination as load, and then C1 C2 C3 in parallel combination as load, like this figure. Moving to the next slide. How to measure L1, L2, L3. If we want to measure L1, then we have to switch off L2 and L3. Similarly, if you want to measure L2, we have to switch off others too. Similarly, we can and measure L3. How to measure LS and LP? The inductor in the picture on the left are connected in series. From the first we have to switch on L1, L2, L3, like this, and like this. On the right side figure, we connected inductor in parallel. This is how the wires should be connected. We have to switch on L1, L2, L3, and connect the two wires of the RLC meter. Two wire of the RLC meter are are 2 ends of the inductor load. Moving to the next slide. How to measure CS and CP. The capacitor in the picture on the left connected in parallel. We have to switch switch on LC1, C2, C3, and food and on the other hand, on the on the right side figure, we connected capacitor in parallel like this. Two years. We have to switch on L1, L2, and L3. And moving to the next slide. Mm, we have we in data table for inductance we have taken 3 ms as L1 and 4 ms as L2 and 5 ms as L3. By calculating we have got the value of Ls equal 12 ms and LP equal 1.27 ms. Data table for capacitance, we have also take 1 microfarad as C1, 3 microfarad as C2 and 5 microfarad as C3. By calculating we get CS equal 0.65 microfarad and CP equal 9 microfarad. Moving to the next slide. Calculation. We know Ls equal L1 plus L2 plus L3. Putting the value of L1, L2, L3, we 3 plus 4 plus 5 equal 12 ms. And we know L equal L inverse 1 plus L2 inverse 1 plus L3 inverse 1 whole inverse 1. By putting the value of L1, L2, and L3, we get at LP equal 1.27 microhenry. And C, by putting the value of C1, C2, C3, C3, and we get CS equal, we have got CS equal 9 microfarad and CP equal L 0.65 microfarad. Thanks. Asla.